Scientists and researchers firmly believe that the particles of matter are in constant motion. The molecules of solids and liquids are limited in their motion compared to gases. They have greater attractive forces that tend to keep the molecules together. When the molecules are held together by these attractive forces, the molecules retain some degree of order. Even though we think of a solid as being fixed in place, the reality is that the solid's molecules are experiencing some type of vibrational motion. Conversely, gases have various degrees of random motion. This belief that matter experiences constant motion is the basis for the kinetic molecular theory. The word kinetic basically implies motion. For studying gases, you need to adopt these basic assumptions of the kinetic molecular theory. A gas consists of a large number of atoms and/or molecules that are in a state of continuous random motion. Even though the molecules move in random ways, the reality is that gas molecules move in straight lines at a constant speed. The quote-unquote randomness is a result of all the gas molecule collisions. Gas molecules are very small and they have great distances between each other. Most of the volume occupied by a gas is just empty space, which is why gases can be compressed. Pressure is due to the force of molecular collisions on a surface. These collisions are elastic in nature, just meaning that they bounce off each other with no loss of kinetic energy. There aren't any significant attractive forces between the gas molecules. The only forces that are experienced are through gas molecule collisions. This is true unless the gases are compressed so close where they can feel attractions to one another. The compressions could be a result of either lower temperatures or higher pressures. The average kinetic energy of a gas molecule is independent of the nature of the gas and is directly proportional to the temperature. When the temperature is increased, gas molecules will move rapidly and the kinetic energy will increase, which causes more collisions with greater force. Diffusion is the spontaneous spreading of one substance through another, which provides additional evidence of the kinetic molecular theory. For example, when you add milk to coffee, even if you don't take your spoon and stir it, the milk is still going to spread throughout the coffee. Because of the color change, you instantly know that this has happened. How would this be possible if the milk molecules were not in motion? It is important that you realize just because your coffee with milk looks uniform in color, that doesn't mean that the molecules have stopped moving just because we do not see the milk spreading out anymore. Again, according to the kinetic molecular theory, molecules are in continuous motion. Let's say you're out in public and it's a windless day. Several yards from you, a guy is smoking a cigar. Even without wind to carry the smoke diffuses outward and reaches you. By the nature of molecular movement, you essentially are secondhand smoking that cigar with the guy. Even though you are several yards away from him, the gas particles in the smoke diffused through the air and went straight into your nose. Diffusion of a substance happens from areas of high concentration to areas of low concentration. The greatest concentration of smoke is around the man, and it diffuses outward in all directions.